Okay, hello everyone, welcome to this video. So for this video, we're going to talk about regression analysis. Okay, so regression analysis for the introduction. First is the father of regression analysis is Carl F. Gauss from 1977 to 1855. And it has a lot of contribution to physics, mathematics, and astronomy. The term regression was first used in 1977 by Francis Galton. Okay, so regression analysis. This is the study of the relationship between variables. It is also the one and the most commonly used tools for business analysis, sorry for that. It is easy to use and applies to many situations. So there are types of regression analysis, a regression, simple regression, and then multiple regression. For simple regression, you can have single explanatory variable. On the other hand, for multiple regression, includes any number of explanatory variables. And when talking about regression analysis, there will be two types of variables. So this is the idea, or this is the model that you can create when talking about regression analysis. First, the dependent variable, that is the y. This is the dependent variable. It is a single variable being explained, predicted by the regression model. And then the independent variable, this one, x. This is also called the explanatory variables used to predict the dependent variable. And this b sub 0 beta, this beta sub 0, beta 1, and beta 2, these are the coefficients or numbers ni siya na siya value. And this e here is the residuals, or what we called error. Okay, the portion for coefficients is the values computed by the regression tool reflecting explanatory to dependent variable relationship. And then for the error, this is the portion of dependent variable that isn't explained by the model and model under the over prediction. Okay, so for example regression. Okay, so before we continue, I would like to cite situation that we're going to use regression analysis. So let's say if we're going to talk about the effect of uh, number of number of hours studying to your grades in mathematics, English, the effect. So that means we're talking about this one, the study of relationship between variables among the grades of mathematics, English, and then the effect of the number of hours you're studying that concept. And in that way also you can predict, you can create, once you run those data, possible data in regression analysis, you can obtain a model and you can predict the future effect of those variables to the dependent variable. Okay, so let's proceed here. Regression analysis, there will be a linear regression and nonlinear. When talking about linear regression, the straight line relationship form of this formula or this expression, y for the dependent variable is equal to mx plus b. M here is the slope or the coefficient, and x here is the independent variable, plus b here is some error. Okay, this is the sum error. And then nonlinear implies curve relationship. That is what we call logarithmic relationship. On the other hand, we also have regression analysis, cross-sectional, and time series. Cross-sectional, that means data gathered from the same time period. On the other hand, when talking about time series data, or it is involves data observed over equally spaced points in time. So, ang basihan ani is, for example, is ang time series is kanang income nimo from month to month ana. So na-obtain ang data from time to time, dili siya the same time period, unlike sa cross-sectional. Okay, so simple linear regression model is this one. For example, only one independent variable, isa ra ka x. Relationship between x and y is described by the linear function, this linear function, and changes in y are assumed to be caused by the changes in x. So, muna siya ang simple linear regression, only one independent variable to predict the dependent variable. There are types of regression models as well. Remember on our discussions talking about correlation or relationship among variables, it has something to do in talking about regression analysis as well. Ang kalainan lang niya is when talking about regression analysis, regression model, for regression analysis, you can obtain a model or katong formula to predict the future values of the dependent variable. On the other hand, for correlation, you're just going to obtain the coefficient or katong correlation value or kato si R to check if there is a strong relationship or there is a strong negative relationship or positive relationship among the variables. But when talking about regression analysis, is more siya mas advanced sa correlation, okay? Although, ang regression analysis is na po ni siya may pagka-correlation gamay because you can obtain the effect or unsay effect sa independent variable towards the dependent variable. Na, more makita po diri ang relationship if there is a negative effect or a positive effect. Okay? And here is the estimated regression model. It looks like this. So sample regression lines provides an estimate of the population regression lines. So as you can notice, paparehara ni siya sa katong y is equal to mx plus b. Ang kalainan lang niya, ang b niya is naguna kaysa sa mx or si b1 as m. Something like that. Pero ani ang concept niya, guys. Si y here is the predicted or the dependent variable. Si x here is the independent variable. B here is just intercepts or mo ni siya ang estimates for error. And then the individual random error terms E have a mean of 0. So na siya intercepts na siya constant. Kani si B is 0. And then B1 here is the estimated regression slope or kato si M. Okay? So simple linear regression example. Here's an example. A real estate agent wishes to examine the relationship between the selling price of home and its size, measured in square feet. A random sample of 10 houses is selected. So, gitanaw niya ang relationship between sa selling price of the home and its size. So, presyo o ang size sa balay. So, ang presyo o ang size, ang dependent here is of course the price. Kay magbase man siya kung unsa kada ang presyo ay ang unsa kada ka ang balay. But the balay here is the independent. It's because siya kanang dili siya mapektuhan sa dependent o ana. Murag naa na siya fix ang size sa balay ana, fix ang size sa balay. And then ang presyo ray magdepende kung unsa ang size ana, okay? So these are the data. And then we input here in the Microsoft Excel. And then as usual, you go to data and then data analysis, and then you can find the regression analysis. Once you click the regression analysis, you can obtain this dialog box. And then when inputting the information or the data to your Excel, you can write it this way, the house price and then the square feet. And then input the Y, just highlight all the Y here, that is the dependent variable, right? So that is house price, so you're going to highlight that one. And then for input the X, that is for dependent variable or square feet, you're just going to click all those. Okay, you click labels, content 0, and there are some other. And then outputs here, you can click new worksheet if you want to have a new worksheet to pop up. And also you can click here some residuals or diagrams that you can use for your further analysis. So there's a residuals, there's a standardized residuals, residual plots, and then line fit plots, and then there's also the normal probability plots. Okay, next. So once you click all those things, ang yang gi-click diri guys is kanila si line plots. But na din siya result of this one. This is the result, regression statistics. So this is the result. And then we also have the Anova table. And then this is the most important table, the regression analysis na nadiriya. So kita ninyo mga coefficients guys. Muna siya ang intercepts, muna siya ang square feet. That means, kani siya nga mga number mo ni ang mo involve or i-include nyo sa formula of this form. Muna siya, di ba? Nga itong independent variable, ani is ang house size. So, independent, that is x, diri ang x. And si y is the dependent. So, you have y is equal to b sub 0 plus b sub 1x. So, muna siya ang forma, guys. Si intercepts, that is the b sub 0. Si square feet, kani siya nga coefficient, mutapad na siya sa square feet. Okay? And then, for the graphical presentation, because we did check the line graph, so we have this one. Kaning dot guys, muna siya ang gitawag og scatter plot, scatter diagram. And then na siya line, muna siya ang slope. O muna siya mag-describe sa ato ang equation. Muna siya itong equation. Okay? So, notice ninyo, pasaka siya, so na siya possible positive relationship or positive effect. Pasaka ma siya. So, then, for the interpretation, we have here house price. So, b sub 0 is estimated average value of y when the value of x is 0. If x is 0, it is in the range of observed. So, kung x kuno 0, walay square feet, ang average yun or ang starting point ana sa presyo, here, no house had 0 square feet. So, b sub 0 is equal to 98 point. Muna siya kanang starting point sa presyo sa isa ka balay. Okay. For houses within the range of sizes observed, is the portion of the house price then explained by square feet. Na siya, guys. So, you can have your explanation this way. And then for the model, so this is what we call model. House price is equal to 98.24833 plus 0.10977 square feet. B sub 1, that is the 0.10977, measures the estimated change in average of value of y as the result of 1 unit change in x. So, you can interpret that this way. Here, b sub 1 is equal to 0.10977 tells us that the average value of the house increases by 0.10977 in every $1,000 is equal to $109 on the average for each additional 1 square foot of the house of size. And then we have here another example. Not really another example. This is just a continuation. House price. So predict. In here, you're going to predict the estimated house price given that you have this one. Predict the price of the house with 2,000 square feet. So in this prediction, substitute lang niya sa square feet and then do the computation. And then you can have here the value. The predicted price for house with 2,000 square feet is $317,850. So we have here another concept. This is what we call coefficients of determination, or the R squared. Coefficients of determination is equal to SSR over SST is equal to sum of squares explained by regression and sum of squares. Total sum of squares. So, in a single independent variable case, the coefficients of determination is R squared is just equal to small letter R squared. In here, ang dako nga R squared is coefficient of determination. Just equal to simple correlation. Ang R put here is a simple correlation coefficient. Or, as you can remember, katong R value, katong itong correlation value nga ito na-discuss in our previous discussion. Correlation. Okay? So, in here, examples of approximates of R squared values. So, na siya paubos, na siya pataas. So, perfect linear relationship between x and y, and 100% of variation in y is explained by variation in x. That is given nga tanang dots ming sunod sa linya. What is 100% variation of y is explained by variation of x. Okay? Given nga tanang dots is naa sa linya. On the other hand, if r squared is in between 0 to 1, we create a linear relationship between x and y. So, notice ninyo, ang mga dots is wala na siya nagtungod or wala na siya ming inline or wala na siya ming touch sa linya ang tanan, but na siya murag trend lang nga, na siya murag trend nga murag way bitaw nga dato padulong pasaka or paubos ana siya trend. Some but not all of the variation in y is explained by variation in x. So na siya, as you can remember katong explanation na to sa correlation mo na siya ang concept, guys. So if 0 ang r squared, no linear relationship between x and y, the value of y does not depend on x. So wala relationship kapag straight nga horizontal, okay? So we also have the Anova table for the regression. So this is what we call the R squared, SSR, SST. So mo ni siya ang SS, diri ang SSR kani siya. I-divide mo na siya sa total kani. Tura can you see it? Na siya. And then when you can interpret that this way, 58.08% of variation in the house price is explained by variation in square feet. Okay? So that's how you're going to explain the R squared nga value. Next is the standard error of estimate. The standard deviation of variation of observation around the regression line is estimated by this one. S sub E, or the error, is equal to square root of SSE over n minus k minus 1. Kaning SSE, guys, makuha dyan po ni siya dito sa Anova table nga nasa result, okay? Where SSE is equal to the sum of squares error, n is equal to the sum size, and k is the number of independent variables in the model. So we have here the standard deviation of regression slope, standard error of regression slope coefficient, or B1, kato si B1, is estimated by using this formula, kato si B1. Okay? Estimated the standard error and then the sample standard error. So, muna siya ang formula, guys. Familiarize lang na ninyo. Anyway, naana na siya. Given naman na siya, guys. Gi-state lang niya ang formula. Given na siya sa result diretso, ha? So, ayan na magka-worry sa formula. So, muna siya, guys. Adjusted R square. Muna siya CSSE. CSB is kani si error. Total residual. Kani si residual. Oh, wait lang. Dili siya maklaro. Aha man niya ikuha si SSB1. 0.032. Okay, let me check where did that go. Okay, so I'm going to try to input the data, guys, on using Excel and try to check where did asa gikuha ni si SB1, okay? Okay, let me. Okay, so actually I did try to solve the SB sub 1, this one, using this formula actually. So I'm going to have I did a manual computation for that to solve this one. Maybe on my next tutorial, I'm going to teach you for my next video, because for this time, I don't have a clear camera to record this one, okay? Maybe I'm just going to take pictures of it on the process of my computation, okay? So for now, that's it. For now, that's it. That's all for some basic ideas of regression analysis. Hopefully you did learn something, and for our next video I'm going to discuss on how we're going to do this, or I'm going to demonstrate actual demonstration using the Microsoft Excel and an actual example for regression analysis. Okay, so that's it, and see you on my next video. Have a great day.